Good afternoon, ladies and gentlemen. This is quite another subject as all the previous talks. What I'm going to talk about is basically about the features of Apache Solar, which is obviously one of the Apache projects and which is also an embeddable search engine that we use for our own search engine that plugs into our content management system, which is PHP based. So what is it in a nutshell? It's a front-end to the enterprise-grade Apache Solar, which is on his turn based on the C libraries written in Java. And then it's a search engine for our easy publish content management system, which is written in PHP. It provides basically all the features that you may want from a search engine, like tunable relevancy ranking, sorting, filtering, drill-down navigation, like facets, which is used on more and more sites and which really helps a user to find quickly what he wants. It also provides heuristics for providing automatic related content. It provides spell checking, highlighting of keywords, and as well as some mechanisms for external content indexing. Now, Apache Solar itself, it has a very nice architecture. And basically it follows a flat database model, document field paradigm that you also may find in databases like CouchDB. That makes it also very much suited for structured content, because with structured content you can apply all kinds of heuristics and rules to influence the relevancy, have filtering and facets, sometimes even much more powerful than you can get from a database. With respect to text and languages, it provides also language-dependent analysis, both at index and at query time. The bindings are very simple. It's a REST interface. It follows through everything over HTTP. And it provides currently quite some response formats, so it's very easy to integrate with your applications written in various sets of languages. It provides XML, JSON, PHP, Python, and so on. Okay, a bit more into the features now. It provides tunable relevancy ranking, both at index time, which you can regard as a kind of really hard-coded way of saying this type of content is much more important than the other, regardless of what the user wants. Or you can do it at query time, when the user searches for it, and provide, of course, with some interface elements to control this process. How does it work? As Solar is a document-oriented kind of storage, I wouldn't call it a database, but it's sometimes close to it. It provides boosting on the documents. Some pages may be more important than others, as well as at the field level. So if some title contains typically the most important words of an article, you can say, okay, if the matches are in this article, the search results will be so that that article will be pushed to the top. You can also influence it in a much harder way. You can, what we call in Solar, elevate predefined pages to the top when certain keywords are entered. This is typically used also in e-commerce applications, where, for example, when you search for iPod, you definitely get the most important pages related to that. You can also tune the relevancy ranking in much more interesting ways. You can use customized functions for that, and that allows you to put more weight on, for example, more recent content, like news. If you have a large news site which has articles over many years, you may say, okay, I still want to have the most recent articles a bit pushed up. Other uses are boosting on geospatial parameters, like proximity searches. If you want to have a restaurant which provides a nice kind of lobster preparation, well, you can search for it and that it's not too far away from you, if your application is designed by that, of course. Filtering and sorting, it's incredibly powerful. It provides fuzzy, Boolean, and all kinds of combinations of it. And it can also be used even to speed up queries of databases. Facets. The illustration here, I think, says enough. On the right, oops. On the right you see a kind of a navigation menu, which just shows the hits for the query that you entered. So basically along the main query you can specify fields like typically metadata as well as queries, and these can be used to build back the user interfaces required to have a very fast navigation to the results he wants. Another nice feature, this is with quite some heuristics, it's automatic related content. This is used, by the way, by more and more large news sites like BBC. And it tries to correlate articles that exist with the page that you are viewing. Basically, it uses heuristics to perform a query in the background and assembles that for returning a normal search, actually, without user interaction. All the features from Sora can be used here, like filtering, sorting, also the facets that I described before. It's really, really, really powerful. It requires some tuning, though. You need to experiment with it before it really starts to function like you want. This is a small example. I hope it is more or less visible. But here on the top you have a part of a page, and the backend search engine Sora is here used. Oops. Once more. Yeah. To search for other articles that resemble the page that you are looking at and provide some content that you may be interested in. Spell checking is provided in two different possibilities, two different strategies actually. You could provide a dictionary yourself with all kinds of terms, or you can use the indexed terms inside the search index. And this is actually recommended because if you have a site with typically proper names or expressions that are not really that common, or names or whatever, you will not find them in a normal dictionary. But since they are part of the content, the spell check becomes then also much more relevant and complete. It is possible to ask for a kind of Google approach, best guess. So, for example, if you look for green bottle, that it will try to put out an alternative phrase entirely. There are much more other possibilities here. It's actually endless with Sora, it seems. Language features. It provides a kind of semantic search, and normally this term should be used in a real semantic language scientific context. But since so many commercial search engines abuse it, I don't mind to do it here as well. Sora is multilingual out of the box, but it is not so trivial. I think it is a bit due to the fact that most of the developers are from the US, and they do not care too much about alternative languages or think that a site should be monolingual. Anyway, what we did is try two approaches. It's an implementation with dedicated fields, metadata fields, which provide just the language in which the page is indexed. That means that there is a common index for all the languages, and it has also some problems with the statistics used to provide the relevancy scores. Because you basically dilute terms between languages, the algorithms to make this relevancy happening don't work so good. So the second approach is what we used is by using shards, which basically creates multiple indexes, one per language, and where you can also apply all the tuning about analysis per language. One of the problems typically is also that all kinds of algorithms like stemming really depend on the language. For English, it's relatively simple. If you look for Dutch, it becomes a bit more complicated. If you go for Finnish, it's very, very difficult. Anyway, but using charts, you can tune per language, as long as your content is multilingual, of course, and then it will work a lot better. Stemming that is used to reduce words to a more common form basically has a side effect that it corrects almost magically spelling errors, although spell checking is provided, as I explained before. Another nice feature in the analysis steps that you can do is activate normalization. For example, Latin 1 characters, the characters you find in French and Eastern European languages or German. They can become all normalized to a common form. The same with the query terms that the user enters. So the match is always there regardless if the keyword was spelled with the accent or not. Another way of catching some of the typical spelling errors is introduced by users. Another nice thing with Solar, which you will not be able to do immediately with the Lucene libraries, but we need it because that's much more elementary, is that there are already mechanisms provided to index the content which could be called external, because usually you use Solar as an embedded search server for your application. And it can do this in various ways. One of the ways that is possible is what is called the data import handler. And it is a mechanism where you just need to configure a few XML files, and that allows Solar to pull content either from a database or from some kind of XML feed or store. That works out of the box and is really important and catches basically quite some application requirements. Other ways to do it is crawling. Why not? What I did, or what we did, was writing a custom plugin, which basically uses Nudge, which is another Apache project that provides crawling, extraction of content with the Tika libraries, and just feeds, in this case, the Solar index by itself. If you have much more complex things, or you need to be much more in charge, which typically is the case with all kinds of content management systems, then you need to write your own plugin for the databases that you typically use. This is basically also what we do with Easy Publish. So, explain it a little bit. The native features of Solar are already very powerful, or you can write custom plugins or use Nudge. It's really a cool project. If some people use Nudge and looked also at Aperture, there is currently work going on to also provide integration between Aperture and Solar. Solar itself is very scalable and fast, although some people always tell to me, hey, this is Java, this must be slow. No, it's on the server side. When the hotspot compiler kicks in, it becomes really, really fast. And typically benchmarks that we did and that other people have done, a normal server can easily serve an index of 10 to 100 million objects with typically 5 search requests a second. The only thing that it needs is memory, lots of memory. One of the reasons that it is fast is actually that it also uses all kinds of internal caching strategies. Typically when you create a cache in an application and something is updated after this, caches are discarded and are rebuilt at the first opportunity that needs it. In Solar it's different, it's proactively. So if a cache exists and it's not valid anymore because you add new content to your database, it will recreate the caches in the background until everything is ready and switches them live so they're immediately available for the next request that comes in. Can easily host typically multiple sites if you think of content management system on one engine. And it has, even for the very large requirements on scalability and performance, kind of built-in clustering. Secure, because it is a document-oriented storage system, you can easily add fields, meta fields, that you can use to implement security as long as your security model of your application resembles a kind of role-based system. The nice thing with that is also that the security rules are converted to cached filters inside Solar, and it really makes it very fast. If you don't have it, usually you're running into big problems if security is needed, because you usually need to do some post-processing on your data for every request. Okay, that was it. For more information, please do visit the Apache Solar site if you have never done it. It's a really cool and very emerging project, especially for web content management systems or any data sources that need to be searched and queried. And it is really relevant as typical websites, if you look at the traffic they get when there is a search enabled function in it, it rises to easily 30-40% of all your visits. If you're interested in our implementation with Solar, which is called Easy Find, you can also find it. We are basically a multinational company with headquarters in Norway. Or if you have specific questions on Solar or Easy Find or whatever related to it, you can email me. It's a very short email address. Okay. Thank you. That was it.